All right, thank you guys for coming. This is an interesting talk because I'm kind of an imposter here. Not really building per se in the SDK or even in Cosmos, but I like to LARP as Cosmos because I've always been a fan. I think IBC is the best bridging mechanism possible. And the work that we're trying to do is really bringing it to Ethereum, other VMs, other ecosystems. Some of you guys may be familiar with the movement. It's more in the Ethereum ecosystem and next-gen ecosystem. Some of you may not. So I'll start with a quick introduction of myself and what we're doing, and I'll delve more in the tech stack and talk about how we're really trying to bring IBC and the Cosmos like principles to Ethereum. Because ultimately, Cosmos is the internet of blockchains, right? It started off as zones and like the fundamental layer ones, like what Osmosis built, but now we really see it adopted beyond Cosmos. Ethereum's using it. We have teams like Polymer, Union, Hyperlane, bringing the principles of IBC and the SDK and Tendermint to alternative ecosystems. And I really think that's where the value is truly captured. How do we bring the fundamental technology that we all love to ecosystems where it can be appreciated? So yeah, Movement, some of you may know it, is bringing the Move VM to Ethereum. For context, Move was started by the Facebook initiative over 6 years ago, I'd say. The thesis was Facebook wanted to basically spar a stablecoin for billions of users. They want to send money from New York to Thailand at the speed of light on the Facebook app. They started the DM and Libra program, put $1 billion in resources, and had every partnership lined up in the book. Around 4 years ago, I'd say, the SEC was like, nah, you can't do that. Thanks, Gensler, you ruined our lives. But spun off to Aptos and Sui, two major layer ones. And then I would say in November 2022, we started Movement, bringing the Move VM to Ethereum. So yeah, M2, a Move-based zero-knowledge rollup for safe blockchains. We'll start with the glossary of terms because some of the terms aren't really used in Cosmos. Go into context, problem, solution, architecture, and where we're headed. So yeah, M1 is our decentralized sequencer network. I'll reference it. We had a few prototypes. We had a Snowman prototype and a new Tendermint prototype that we're really excited to share. We have M2, which is the main layer 2 on our network. We have a virtual machine. You guys all know it. You guys mostly familiar with COSM, WASM, and some EVM mutations. But we're focusing on the Move VM here and also EVM compatibility. And EVM is hot garbage. We all hate it. That's why we're trying to fix it. Movement SDK, it's a software kit to execute smart contracts. I would say the Cosmos SDK is more focused on spinning up layer ones. Our Movement SDK is focused on spinning up novel virtual machines and execution environments. Move VM is like the technology we're referencing. Fractal is our EVM interpreter, which I'll get more into later. And a zero-knowledge proof, you guys get that. And DA later, don't explain that. So context, Solidity is hot garbage. Who here has got rugged, scammed, hacked, or somehow destroyed by the EVM? I can do a show of hands. Cool. Every year, there's 7.6 billion USD volume lost. And it creates barriers to entry, right? If my mom ever wants to use crypto, she probably doesn't want to get hacked every time she uses Curve, Aave, Uniswap. Here's a breakdown of all the attacks we're seeing. So 17% in private key compromised. There's like re-entity attacks, access control exploits. A lot of the things are arithmetic mistakes. So recently we saw a lot of attacks on Arbitrum, where if you have integer overflow or you have type mishap, that can lead to millions of dollars lost. So there's a $50 million hack on Arbitrum. I think it was like 3 days ago. That was simply because they did an arithmetic error wrong. And that wasn't their fault, right? They weren't trying to rug the chain. There was just developer mistake that was like the 25th commit that day. And that really creates a lot of issues because if you're like a normal developer and more unskilled developer, it's really difficult for you to constantly publish new code and get it constantly audited. So this is the problem statement, and this is why we're all in crypto to solve this, right? Everyone's focusing on speed and creating scalable systems, but we're all putting money on chain. How do we stop these attacks from happening? So like I touched on, the Move language was built by Facebook in the DM program, essentially a resource-oriented programming language. I'll get more into that, but really focusing on formal verification. There's some auditor in this room, and that's kind of where this is geared towards, but formal verification is what you do when you submit your code. You have a great PR, you put it to auditor, they'll charge you 100 grand. Thanks, AutoSec, I see in the corner. But yeah, anyways, we're trying to do that at runtime, where essentially when you publish a smart contract via the execution environment, you're able to check for novel mishaps. So if you have the integer overflow, if you have a resource issue, the Move prover can stop at runtime and be like, hey, you actually have a memory leak. Let's stop it from compiling. Solidity and other types of VMs doesn't have this checks, even Solana. So when we look at Kyber, Curve, the DAO, these are major attacks that could have been simply stopped if you just had formal verification at runtime. So So can we enable safer smart contract execution environments within the Ethereum ecosystem? Can we bring Move to Ethereum? Yes, a Move-based rollup on Ethereum. I'll do a quick primer rollups. I don't need to go to this because I'm assuming there's general context, but you have two main categories of rollups: optimistic, which uses fraud proofs and has challenge periods. You have ZK rollups, which have validity proofs, fast but computation expensive. The main ZK rollups in the market are very expensive and need a lot of users or transactions to actually scale. I believe Scroll is like $3 a transaction right now, and ZK Sync is somewhere around there. While the more optimistic rollups are cheaper. So yeah, what we are doing, M2, a Move-based $0 rollup. Why M2? Safe execution environment. So you have all the principles of formal verification. Most normally it's a ZJ solver. So when you execute a smart contract, you essentially check for resource type, memory safety, runtime. You have Boogie 3 solvers that check, hey, is there integer overflow? Is there memory leaks at runtime? Use zero-knowledge proofs of validity. We're starting off with optimistic rollup just to get to the market, but we have a full end-to-end ZK Move VM architected. It's just computationally very expensive. It's around like a cent or 2 cents per transaction, which is pretty expensive. So once we're working with a few partners to bring those costs down, like proof aggregation stuff. And yeah, being on Ethereum, which is really important. For context, I built one of the first applications on Aptos. It's quite difficult because there's one token and a testnet token, which meant the DEX was kind of useless. So now that same DEX can deploy on top of us, have native ETH, be on Ethereum for settlement liquidity, as well as a full end-to-end even compatibility, which is pretty exciting. Here's a bit of architecture, and I'll go into each one of these things. But essentially you have SDK, which is involved for execution, sequencing, and block building. You have data availability services where you publish call data to. You have a proof marketplace, which generates these proofs, and you post state root to the L1 blockchain, which is Ethereum. But we've seen other use cases of Bitcoin rollups. So we have a team doing movie on Bitcoin. We have a team doing it on Solana even. So it's pretty exciting. What's interesting about our stack, and probably more the technical pieces, is the even compatibility. I know Cosmos experimented this with the DEVMOS and Berachain and other integrations where you're trying to bring a novel virtual machine to a new stack. What we're trying to do is make our stack as end-to-end even compatible as possible, where we're able to take Solidity contracts, Move contracts, and compile it down to one basic virtual machine. Solana tried to implement this with the LLVM. Basically, they're able to have different compilers compile down to LLVM, but this creates a lot of performance issues. Move on Solana makes fundamentally no sense because the main value prop for Move and the Move language itself is the VM itself. Having the Move prover at runtime enables you to have the block STM, which is the main consensus engine, as well as having the Move prover. However, with the way we architected, we actually have an interpreter that's built at SDK. It's similar to like Solang on Solana and like Neon if Neon wasn't Neon. Neon has a bridge essentially where you bridge the EVM to Solana, so it's like a layer 2. That creates a lot of problems because you're still relying on a third-party bridge that can get hacked. And you can see by Neon's adoption today. Hopefully no one Neon's here. So the way we architect is any Solidity contract can run. It deploys on the Fractal, which is an EVM interpreter. You boil it down to Move bytecode and launch in the VM. I'll get more into that. This is kind of how the architecture looks like. You take the Solidity script, parse it to an abstract syntax tree. That goes to intermediate language, which is called YUL. It's similar to assembly. You have like 142 Solidity opcodes, I believe, and you map that to the 54 opcodes to the runtime. You're mainly translating accounts and tokens. There's full end-to-end pre-compiled support except for EC add, EC pairing, and EC cache, I believe, which are only used in Tornado Cache. So Tornado Cache doesn't work in Movement, but I think we're good with that for legal reasons. But everything else works out of the box: lending protocols, DEXs, gaming, etc. So if you have Uniswap, it takes 10 minutes to deploy on MoveVM, which is really cool because this brings you to the parallelized EVM concept, which obviously is a hot topic, but this is able to be accomplished at an interpreter without any loss in latency or whatever, because you're simply doing it at SDK level and mapping the opcodes. And because Move has fewer opcodes, you can solve the security checks that we have the VM. Get more into this. So yeah, on the decentralized sequencer, I would say most L2s kind of need to obviously need to decentralize. The questions like Base, Optimism, Arbiter are making a lot of money. So how do we force decentralization? Because we have a high throughput engine, we actually need a decentralized sequencer. Most L2s tap out 100, 200 TPS. but we're looking to optimize the Solana-like UX on Ethereum. So to that extent, we have a fully decentralized sequencer. Obviously, you have no central point of failure. You have fairness in terms of MEV, and your censorship resistance. But how do the sequencers reach agreement, and how do the sequencers chosen? So we actually started our first prototype in Avalanche, which is probably a contrarian take here. Most people probably hate Sonoma consensus, but we really liked it because there's a leaderless BFT consensus mechanism. You have like metastability, which gossip subset of peers. It's essentially a fork of Avalanche's main layer 1, but we have total ordering built in it. But I think the issue they recently ran is that there's no finality gadget built in Snowman. So we actually recently opted for a Tendermint consensus that we have prototype. So some people were happy about that. We're actually releasing that in 2 weeks, open sourcing it. So similar to Astria's, I would say I think Astria is based on Tendermint, but we completely scrapped it and focused on how do you, if you have 2 parallelized rollups, how do you sync state across rollups? So we're excited to share that this month. So keep eye on that. The main thesis is proof of stake. Going back to token economics, like most L2 tokens are meme coins. They're all governance tokens that actually have no value accrual. All the L2s are promising decentralized, but they're like, yeah, we'll eventually do that. That's probably 3 years from now. We're going to have this at mainnet or as close to mainnet as possible, where the token actually has value accrual, where validators are incentivized to stake the token because there's buy pressure there. If I stake the token, I get emissions, obviously, but I also get sequencing fees from the layer 2, as well as other layer 2s in the network. So you actually have this network effect where there's buy pressure for the token because people want to stake the token to earn fees and use that to run more and more nodes. And eventually you want to be permissionless. Obviously, Tendermint kind of taps you out there, but for the sake of this, I think 100 nodes is more than sufficient for the next few years. Yeah, so sequencing network, you have clients, full nodes, proving data layer. We go to this section. On the prover marketplace, this is something where we're actively working on because proofs are very expensive, as I'm sure you know. If you're trying to build a next-gen network and you're paying 3 cents per transaction, you're going to get simply wrecked by any other layer 1. So working with a few of the prover marketplaces to try and see if we can aggregate proof for cost. So I think the Polygon CDK is really interesting for ag layer because when you have a single proof, you're actually splitting the costs amongst the entire rollups. So in theory, you can get proving costs down to sub-cent, even like fraction of a cent. Our current architecture adapts Plonky 2 for the Move VM, which has field encoding, custom gates, and optimizations, recursive proof generation with compact size. Let's see if I can get more into that. Let's see what it is. Yeah, so the intermediate goal is M2 is optimistic rollup. That's what's on testnet right now. You can go docs.movementlabs.xyz, deploy contracts. We support Aptos Suite and EVM contracts. Currently architected with ZK fraud proofs. So it's actually like the intermediary between optimistic and ZK rollup. Validity proofs where you're still able to have a challenge period, but you only do it when there's a challenge. So it's a lot more computationally cheaper. Right now you can use like risk0 and succinct for generating these proofs. Executions SDK. M1 is the sequencing. I think you'll probably end up being Tendermint, so excited about that. Yeah, where are we headed next? Having the SDK for the Move VM, Fractal, and de-incentivization. I think the overall thesis is how do we create use cases for all this infra? Like we're all trying to build layer 1s, layer 2s, but how do you connect this broadband network? Which is where, I don't know the things in the deck, but where IBC gets really interesting. Right now we're working in Union to build out Sol-like client machines for a layer 2. And that allows you to have Noble and all like the Cosmos assets coming directly to the layer 2. But it's also a world, I talked to Helena like 3 days ago, that we can potentially integrate the Sol-like client machine as a single centralized sequencer. If you start off centralized, if you decentralize sequencers, it gets more difficult. But working with parties like Union, Polymer, et cetera, enable us to connect Ethereum and broader VMs to the Cosmos community that you guys built here. I think my time's wrapping up, but thank you.